Hi everyone. For this question, we're going to find the area enclosed by the following curve and the straight line. So first of all, we have a quadratic curve. So for this quadratic curve, it is positive quadratic x squared, so it will be graphed on the smiley face here, and we can find out what is your intercept when x 0, y is equals to 1. As you observe our quadratic y equals to ax squared plus bx plus c, when our quadratic don't have bx term, which means that this quadratic is symmetrically at y-axis. So it will be in the center of, for the y-axis. Y-axis will be center of this parabola. So therefore, our graph here, to drawing this quadratic, when x equals to 0, y is equals to 1. So this is the shape of our parabola. Don't forget to label our graph x-axis and y-axis. Secondly, for another graph here, which is our straight line, y equals to x plus 3, we calculate when x equals to 0, y will be negative 3. So this is a gradient positive, y equals to ms plus 3. X here, coefficient is positive, so this graph is going up. So when x equals to 0, this is minimum, we have 1. Y is equals to 3. So it will be intercept higher, so the graph going up. And intersect with y-intercept is 3. This is y equals to x plus 3. And the region bounded by this quadratic and the straight line will be this region. So observe this region. Now we want to find out whether we want to do this calculation of the area using dx or dy. So dy means we're going to do it horizontally, which is, we can see here when we're doing, observe this region horizontally, the graph is touching back itself. So you can see the blue color graph touching back itself. So which means that dy is not suitable in this calculation. So then the only choice will be doing dx, means we're going to offset it vertically. As you can see, when I shade it vertically, always the green color graph going to the blue color graph. It didn't touch back itself. So this is our lower limit and this is our upper limit. So doing our area using dx, the formula will be area equals to lower limit a to b. So two curve concept. Why this two curve concept? Because you can see this region is not directly attached to x-axis. It is detached. It is above from the x-axis. So two curve concept, it will be curve up here minus the curve down here. So fx minus gx, and we're going to integrate with respect to x. So first of all, we want to find out what is our intersection point here. To find intersection point, we need to do simultaneous equation. So y equals to x squared plus 1, equation 1. Another equation will be y equals to x plus 3. This is equation 2. So let us substitute this equation 1 into equation 2. We will get x squared plus 1 equals to x plus 3. Form out a quadratic, so we rearrange it to the left hand side. So to find the x, we undergo factorization and we find out the x value here. So you can use your calculator. You get x negative 1 and x equals 2. So factorization x plus 1 and x minus 2. So here we have negative 1 and this is our value of 2. Now we proceed to find out what is our area. So area is integrate from the lower limit negative 1, upper limit 2. The function at the above will be the linear function minus the function at the below of the region here, the boundary below here will be your quadratic function. So minus in the bracket x squared plus 1. Don't forget to you put your x bracket here, or not the negative will minus x squared but not minus 1. So for this, we can simplify first. As you can see, x 3 can minus 1, we get 2. Then now we can start integrate. So x here, individual x, formula of integrate, power plus 1 over new power. Integrate constant, we get linear. So this one again, power plus 1 over new power. And upper limit is 2, lower limit is -1. The step after this will be upper limit minus lower limit so that we can get to the final answer. So put in 2 square over 2 plus 4, and then this one -8 over 3. If you want to put in one by one also can without calculate, so we just put in the bracket -1. So finally we press calculator, we can get our value of the area here. So that's all for this. Thank you for watching.